recording now. I don't know if you actually went back and looked, but it's the answers to all of the stuff that we've been doing. So that textbook question is page 178. So if you go take a look on this page right here, it says page 178. So and it follows that these are the questions these are the answers to the questions I assigned. Now the danger in giving you this is that you just go and look at it and be like, yeah, so I could totally do that, which I can assure you is not true, because that's how I rolled for a whole chunk of grade 8 and grade 9. And every time I did that, I'm like, oh, here's the question. I'm just going to flip to the answer key. Oh, yeah, I could totally get that answer. Spoiler, I could not. So you actually need to go and do the work, then check your answer, which I know telling a grade 9 to do that, because I was once in grade 9. What did you say, 23 years ago? It's a long time ago. I, too, was once a grade 9 math student. And I know what it was like to have the answers at my disposal. But here they are. With great power comes great responsibility. Don't screw it up. That said, the work I assigned you yesterday was not abundantly difficult. Would anyone like me to go over any part of what I assigned yesterday? I wanted you to do 2 to 14. So starting up here, students often mistake x equals 3 for a horizontal line instead of a vertical line. Why might they make this mistake? Or any of the other big chunk of questions I assigned. Is there anything there anyone would like me to do? Josh. Question number 4. Really? You want me to do question number 4? Okay. Well, they gave you 4 equations, and they said which equation describes each graph. Well, there's 2 graphs, and you just have to tell me which of these equations go with these 2 pictures. This one has a vertical line. The vertical line is over here where x equals -2. So x equals -2. This one has a horizontal line where y equals -2. So y equals -2. And we're done. That's it. It was not that's question 4. The answers are okay, no, the answers are at the back. So well, let's go through them all, I guess, then. That's going to be horizontal, vertical, horizontal, oblique. X means it's vertical, both means it's oblique. Number 6, describe each line. This one is horizontal, that one's vertical, that one's horizontal, that one's vertical. Nope, I swatched those 2 around. That one's vertical, that one's horizontal. And if I'm asking you for a description, this is graph each line to check your description. I'm going to assume that you did that. Write an equation to describe each line. This one's going to be y equals 2, x equals 1, x equals -5. Which equation best describes the graph? Well, this equation here, if that's 1 and that's -1, that's -2, this is going to be the line x equals -1/2. So you have to go through these guys here then and isolate for x to figure out which one of those is going to do that for you. Yes? You sure you don't ask that question? Okay. So it's a vertical line. Vertical line means x is locked, y can be anything. So it's going to be an x equals something. And that's between 0 and -1. Looks like it's halfway. So it can't be a y question. It can't be that one. If I solve for this, that's going to be x equals 2. Obviously not that. This one's going to be x equals something positive, because I'm going to add that 1 over first. So it's not positive, it's negative. So the answer's got to be B. Without actually having to solve this thing, I can see that by process of elimination, the only available answer to that question is question B. So that was number 8. 9, I saw lots of you working on yesterday. That was great. Let P and Q represent the 2 numbers that add to 15. So lots of you wrote down that P plus Q equals 15, and then you made a table of values of P's and Q's. We had things like 7 and 8. We had 6 and 9, 5 and 10. But the numbers can keep going. You could have 8 and 7. You could have 9 over here and 6 over here. You could have had negative 20 and positive 35. Like, however you wanted to throw the numbers down, as long as the pair adds to 15, you're good. So when you graph the data, should you join the points? Can you join the points? Are you allowed to have fractions that add to other fractions to get you to 15? Yep. So because you are allowed to have fractions in there, yes, you would join the points. Yes, you should. Because I could put like 14.5 and 0.5, that would work. I could have 14.9 and 0.1. I could have 14.999 and 0.001. Like, you could have any decimal, any fraction, as long as the two numbers added to 15. Oh, and then the equations right here, which is really what we should have started with, but that's okay. 10, for each equation below, make a table of values and graph. So I'm going to assume that you did 10. For 11, you'd have to isolate each one of these for the given variable. This would be y equals -5. This is going to be x equals -2. This is going to be x equals 3.5. Because 7 divided by 2 is 3.5. And this one's going to be y equals 6. And then you'd graph this. Horizontal line, vertical line, horizontal line, and then just at the right spot. The rectangle wasn't shaded in question 12. It didn't photocopy shaded, but there is only one rectangle there. Josh, what are you doing? Faison, if it doesn't belong to you, don't touch it. Okay, guys, if things don't belong to you, just leave them where they are, unless they're in your way. And then Josh, you shouldn't have it in his way if it wasn't his way. I don't know why you did it way you did. This is the only rectangle actually enclosed by lines. So that's your rectangle. You want to write the equations of the lines that intersect to form the rectangle. So you're going to get, there's going to be an x equals, an x equals, a y equals, and a y equals. The x's are the verticals, so -1 and 4. The y's are the horizontals, so this is going to become, there's going to be a -4 there and a +3 there. And then 3 and 4, I wanted, or 13 rather, and 14, I wanted you to do 2. 13, this thing looks like it's going to form a, looks like a rectangle. Is it going to be a rectangle or is it going to be a square? Nope, it's totally going to be a square. Because it's going to go from -3 to 1 and then from 2 to -2. That's 4 in every direction. This is definitely going to be a square. Congruent means, which is a word you should have looked at in middle school. A congruent shape is one that's the same size. So you would have just needed to create 3 more equations because it wants with one of the vertices at the origin. Ooh, actually, that would have been a fun one to look at. Oh, construct a congruent shape on the grid with one of its vertices at the origin. So a vertex, that's just a corner of the shape. So it wanted you to create another square with a corner at 0, 0. Nobody asked me about that yesterday, so either you did it and did it perfectly, or you didn't do it. Because you all had time to get to this point yesterday. You had 40 minutes. If you guys didn't finish the work in 40 minutes, you should have. Is there more than one shape you could draw? The answer is yes. There would be 4 of them you could do. You could put any one of the 4 corners. Actually, yeah, 4 of them. And then question 14, the distance between Edmonton and Calgary is this. So 14 is actually basically the same as question number 9, except you're adding 2 numbers to 300 instead. So you're going to get 0 and 300, and then these numbers, as you leave Calgary to drive to Edmonton, as someone with family in Edmonton, I'm not sure why you'd want to leave Calgary to go to Edmonton, because Calgary is the nicer of the 2 cities. With family in both places, actually. I got family in Calgary and family in Edmonton. It's really, have you done the drive from Calgary to Edmonton or Edmonton to Calgary? like as you leave Calgary, it's like the signs are depressing kind of as you go towards Edmonton. And as you leave Edmonton, it's like, oh, the sun is shining and you're going to Calgary. And this is how the Albertans have set it up. It's kind of weird. But Edmonton, being further north, is colder, darker, more miserable, depending on the time of year you go there. I've been there in the winter. But Calgary floods, so they both have their pros and cons. But Kate decides to leave Calgary and drive to Edmonton. Maybe it's flooding in Calgary, because it always does every year. As you travel away from Calgary, your distance to Edmonton is going to go down. So like 1 and 299, 50 and 250. And eventually you're going to reach 300 kilometers traveled, and now you're in Edmonton, distance is 0. So you're graphing that. The greatest value of, I don't know why it's T, I guess it's T for 2, or T for traveled maybe. The greatest value traveled is going to be 300, because once you're in Edmonton, you're done. And then you're graphing that. It's going to look an awful lot like the plane descending graph that we did yesterday. That's it. Let's make things more interesting today. Here we go. So find me this page. We're going to graph a whole bunch of things. There's a bunch of examples that we're going to look at today. There's stuff that we're going to talk about. And we're going to develop an equation or a set of equations that's hopefully going to give us an overall idea for the kinds of equations that linear relationships should look like. So buckle up. I have more to say today than I did yesterday. So we're going to graph a bunch of lines. I want to graph the line y equals x, first of all, and see what happens. The line y equals x is really quite a simple line. If I throw a table of values down here for x and for y, and I graph this thing, if x equals y, and I tell you that x is equal to 1, what's y have to be? 1. So if x is 2, then y is 2. If x is -4, then y is going to be -4. Like y equals x is the simplest oblique line you can draw. It's going to go, so I'm just going to plot these points here and then connect them. So we're going to have 1, 1. We're going to have 2, 2. We're going to have -4, -4. The minimum number of lines you can have, points you can have to make a line is 3. I've got my 3 points here. And so now we can just connect those dots. It's just going to look like this. It's going to go through the corner of every square. It's going to be really quite nice. And it's just going to go forever that way. And forever this way. That is the simplest line we can draw. It goes through the origin, because y equals x when x is 0, y equals 0. Simple. So let's do the next one. We're going to graph y equals 2x. We'll throw down a table of values, pick 3 points. Josh, give me a number for x. Jeremy, give me a number for x. And Scarlett. -7. Can you pick not -7? Can you not go further than -5? Just for reasons? -3? Okay. For reasons. Let's keep it not -7. Okay, so this is the equation. Y is equal to 2 times x. So if x is 3, 2 times 3 is? Oh, who picked 4? Jeremy, I need you to pick a number smaller than 4. Okay, we're going to make it 2. We're going to change 4 to 2. For reasons. Okay, 3 times 2 is? Thank you. If x is 2 and y is 2x, then 2 times 2 is 4. And -3 times 2 is? -6. And now we're going to graph these points. Do you see why -7 was a bad number now? So 3, 6 is going to be 3 in the x, 6 in the y. 2 and 4 is going to be 2 there and 4 there. -3, -6 is going to be 3 to the left from 0, and then down 6 from that point. So we're going to get something that looks like this. And now we want to connect those dots. Actually, we can add some more dots in here. Look at the pattern. If I go from this dot here to that dot there, what do I have to do? Awesome job. Oh, to get from the top to the bottom one. Yeah, I'm going to go left 1 and down 2. So I can do that again. I'm going to go left 1, down 2, put another dot. 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 Left 1, down 2, and now we're at the dot we had before. And now we can connect all those dots. It's linear, so there's a pattern. And this is going to go forever in either direction. Interesting. Let's do another one, shall we? Put that guy there. Okay. I want to pick some values because the values we're allowed to have now are getting more and more restricted. Let's look at -2, 0, and 2. I love when I gave you guys values. Nobody picked 0. Gave you guys the option to pick values. No one wanted 0. We like 0. 0 is always good. So let's plug them into this equation. To get y, we're going to take x and we're going to multiply it by 4. So -2 times 4 is -8. 0 times 4 is, and 2 times 4 is. Okay, so let's plot those points. -2 and -8 is way down there. I went left 2 and down. 0, 0 is right there. And then 2 over 2 up 8 is right there. So there's a little pattern we could use here too to make sure to see if there's anything in between that we could do to make our life a little bit easier. To get from the middle point to that upper point there, we'd have to go over 2 and up 8. Is there an in-between step we could do instead of over 2 up 8? Hassan Jot sees it. Right 1, up 4. You betcha. Because if I go over 1, up 4, and then over 1, up 4 again, I get to this point here. To get from the middle point down to the bottom, instead of going right 1 and up 4, I could go, yeah, over -1, down -4, and then do that again. And now I've got you can see we're starting to generate a pattern. And now I can connect these dots. I'm hoping we can start to see a pattern of what's happening here. What's happening is that number multiplying in front of the x is getting bigger. What's happening to the line? Longer? More vertical? What's another word we could use for more vertical? Well, they're all straight. Yeah, it's not curved. It's because I'm freehanding it, but it's not. These are all straight lines. What's another word for more vertical? Starts with an S. Yeah, I thought you were going to say. Sorry? Did you say it? Steeper. More vertical is steeper. So as you can see here, the number in front of the x when there is no number written is a 1. This is the line. 2, you can see it. It's the steepness has increased. 4, the steepness has increased. And 6, well, let's just tack that on there. 6 should be even steeper. I'm going to go -1, 0, and 1. Negative 1 times 6 is negative 6. 0 times 6 is 0. And 1 times 6 is 6. So I'm going to plot these points on the graph now. 1 and 6, 0, 0, negative 1, negative 6. And I'm getting something that looks like this. I'm hoping we can see here that as those numbers are getting larger, these things are going to get steeper. So I don't think I actually make you do it. No, I don't. What do you think would happen if I put decimals in front of the x here? Like instead of going y equals 2, I said y equals 0.5. It would get flatter, yeah. The steepness would decrease. So for numbers here that are bigger than 1, you're getting steeper. As this value gets larger, you're getting steeper. As this number gets lower, like approaches 0, it gets shallower. So you'd get something that looks like this instead. So what would happen, do you think, if the number went, so here we are at 1. As we get closer to 0, it's going to flatten out. Because y equals 0 is this horizontal line. What do you think is going to happen if this number out front starts getting negative? It's going to keep rotating. Interesting. Nobody? It's too early in the morning for mind-blowing mathematical revelation. So what changed in the equations A, B, C, and D? The steepness changed. And how do the lines change in each graph? The bigger the number, the steeper the graph. That's it. So we've got some numbers out front there that have meaning. The number out front of the x gives you a steepness. Interesting. We have a word for that. But I'm not going to tell you the word yet. We're going to flip the page. So these are going to be similar. These are almost the same as the previous one, except now they're all negative. So I want to pick the same values that you guys picked before. X and Y for this first one, you guys said 1, 2, and negative 4. So in this equation, y equals negative x. If I plug 1 in there, if x is equal to 1, then this one's just going to be negative 1. Y is equal to negative of x. So if I plug x is equal to 2 in there, what's y going to be? Negative 2. And if I put x is equal to negative 4 in there, y is going to be positive 4. Because the negative of negative 4 is positive. And so we can just graph these points. When x equals 1, y is negative 1. When x equals negative 2, y is negative 2. When x is equal to negative 4, x is equal to positive 4. And you can just cut through all of the corners of all of the squares, and we're going to get a line that looks like this. Similar to the one we had before, except what happened to it? How is this one related to this one? Anybody? Second period on Wednesday, you guys should be a little bit more awake. Bilal. Yeah, it's going backwards. We flipped it. We rotated it. Yeah. So let's do the next one. Y equals negative 2x. The values you guys picked before were 3, 2, and negative 3. So let's take a look at those values. X and Y, 3, 2, negative 3. If I plug 3 in here, I'm going to get, what's 3 times negative 2? Negative 6. If I plug 2 in here, I'm going to get, and if I plug negative 3 in there, I'm going to get positive 6. So let's graph those points. 3, negative 6 is going to be 3, negative 6. 2, negative 4 is going to be 2 and then down 4. And then negative 3, 6 is going to be left 3, up 6. And the pattern that we had before is going to stay the same. Except this time it's going to be, to get from this point down here to the next point up, is left 1, up 2. So we're going to go left 1, up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1, up 2. And we've got ourselves a pattern it was negative. So now we've got the same kind of thing. It's been flipped the other way. Instead of going up to the right like these ones were before, up to the right, we've got something that's going up to the left or down to the right, yeah. So having that negative outside should be giving us an idea of what's going on here. Should I do these last two or do we want to skip these last two? Do we have an idea of what's going on here? Okay, so what changed in these equations? Or in these graphs, rather. In equations A, B, C, and D, the number was getting more negative. The number got more negative. So the lines were, again, they were changing in their steepness, but they were pointed the other way. Okay, they changed in steepness again. But if you're looking at them from left to right, they were going down instead of up. So then the only difference in the equations from number 1 to number 2 were the negatives out front. The negative sign was the only difference in those equations. And how did those lines change? Well, Bilal said it already. They flipped. So changing that number out front changes the steepness. Changing it from positive to negative flips the thing. Interesting. Flip the page, and they're all graphed for you here so we can talk about them. So let's put all these ideas together. The lines got steeper, putting all of these ideas together, as the numbers in front of the x get bigger. And the direction of the lines changed depending on whether it was a positive or negative. If it's positive, the line goes up to the left, or x and y increase together. If this number is out front is negative, x goes up, y goes down, or vice versa. They flipped. Interesting. Flip the page. We give a name to this concept. We say that the measurement of the steepness of a line, or even if you're out in the world, if you've driven up, so those of you who say you've done the drive from Calgary to Edmonton, it's pretty flat. The slope there is going to be 0. But if you've driven the drive from BC to Calgary, that's a whole nother awesome experience, because you've got a set of mountains in the middle called the Rockies that you've got to go through. And so we measure, the road gets steep. Depending on which path you take, it gets different degrees of steepness. And we call the measurement of steepness the slope. This is the measure of the steepness. If it's positive, you're going up. If it's negative, you're going down. If the number is large, you're going, it's very steep. If the number is between 0 and 1, it gets shallow. If it's 0, it's flat. And we give that letter in the general equation that we're going to put together. The slope is given to us by this letter m here. That value that's multiplied in front of the x, in general we call it m, and it is a measure of the steepness. So the number in front of the x is called the slope. M is used to represent the slope, and it is the rate of change between x and y. So I'm going to flip back. You don't actually... No, I'm not going to flip back because we're going to do it down here at the bottom. It's going to relate to something we've already done, but I didn't use the right language the first time. So in other words, another way to think about the slope is that as I move from point A to point B, or any 2 points on the graph, Hossenjote demonstrated this for us on the previous page. He said there was a pattern. I could go up 1 and over 2, or I could go up 2 and over 1. Like there's a pattern that we follow to get from one point on the grid, on the line, to another point on the line. The slope tells us how you go up and down and how you go left and right. We give that idea, the up and downness, we call the rise, and the left and rightness, we call the run. So this number here is the up, down. This number here is the left, right. Or, when we were looking at table of values, if I want to talk about the up and downness of it all, up and down is a change in what variable? Up and down is a change in X or Y? Up and down is a change in Y, you betcha. And if M is equal to a rise over a run, let's put the division there, a change in the run, or the change in the left and rightness, is equal to a change in X. We've looked at this already. One of the ways that I told you way back, probably 2 or 3 days ago now, of how to determine whether a table of values is linear is to look at this ratio. I think actually Carson is the one that gave it to us in this class. Yes, it was. Pretty sure it was you. If the change in Y over the change in X is the same for every jump, we had something that was linear. We talked about it then. I didn't give it a name. It's named this thing here, the change in Y over the change in X. That's the slope. We've played with it already, but now it's got a name. So if this slope here is positive, it means we're moving up and right. If the slope here is negative, it means we're moving down or left. If they're both negative, this is the same as having a positive slope. So let's actually go play with it. I've got this equation here, y equals 2x. Sorry? It will be, but I'm not there yet. Lucas wants to put it in there, so let's put it in there, -4. But I'm not there yet. What we're going to do is we're going to take this y equals 2x, and we're going to write the slope as a fraction. So instead of having it y equals 2x, I want to write it as y equals something as a fraction times x. Now the whole number 2 can be written as what fraction? 2 over 1. And so if this is the same as the change in y over the change in x, what this means is that as y is going up 2, x is going to go up 1. So Lucas gave us our first value here. He said that y is going to equal -4. If I plug -1 in here, I'm going to get -2. So let's take a look at what we've got here. If we analyze the table of values, x is going up 1, y is going up 2. Interesting. 0 is going to become, 0 times 2 is 0. Sorry? It is linear. That's going to be 2, that's going to be 4. As x rises 1, y rises 2. This is going up 2. This is going up 2. This is going up 1. This is going up 1. It is, in fact, linear. And there's a direct relationship between the equation and the change in y over the change in x. This concept that we looked at before. Every time x goes up 1, y goes up 2. So we can graph these. I'm going to start in the middle with 0, 0. We're going to have 1, 2. We're going to have 2 and 4. And then the other way, I'm going to have -1, -2 is that guy there. And then -2, -4 is that guy there. And we can follow the pattern. To get from one to the next, we go left 1, up 2, left 1, up 2, left 1, up 2, left 1, up 2. You're right. My lefts and rights are backwards. Right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2. Or we could go left 1, down 2, left 1, down 2, left 1, down 2, left 1, down 2. This slope gives us a pattern to follow to generate the line. Which means as you get used to that, you can stop doing this. The whole point of having an equation then that has a relationship phase on is that we can stop doing tables of values if we can identify what pieces in here tell us what information. Fascinating. When you're ready, flip the page. We can stop guessing and checking. We can stop plugging values in. Okay. So we talked about fractions before. Let's talk about fractions again. I mentioned them briefly. Let's see what they do. If I have y equals 1/2 x, we said before that as the y value, as that number in front of the x, now we're going to call it the slope, as that slope gets larger and larger and larger, the line gets steeper and steeper and steeper. I asked you then at that point, what happens if I drop below 1 and start to approach 0? Austin Joe said, well, the line should start to get flatter, approaching maximum flatness. Well, let's verify that. Let's see if that's true. If this is a half, what smart values of x should we pick? Evens. Fantastic. So the ultimate even number is 0. We'll start with 0. And then I'm going to go -2, -4, and 2 and 4. Why not? Let's do all 5. That was weird. Okay. Oh, that wasn't weird. We have an angry IB student. I have -4 times a half. What's half of -4? -2. What is half of -2? What's half of 0? What's half of 2? What's half of 4? Okay, cool. Look at what's happening here. As my x's are going up 2, what are my y's doing? Look, the change in y over the change in x, 1/2. Now let's look at what this does on the graph. Let's plot these points. -4, -2 is left 4, down 2. -1, -2 is left 2, down 1. 0, 0 is right there smack in the middle. 2, 1 is right 2, up 1. And 4, 2 is right 4, up 2. Oh, look, the pattern. Over 2, up 1, over 2, up 1, over 2, up 1, over 2, up 1. The rise over the run, or the change in y over the change in x, the slope, gives us that. And just so we can compare it to y equals x, let's put y equals x in there. Y equals x is just a diagonal line that cuts through all the squares nicely. Oh, look, if this is y equals x, as Hassan Joe predicted, this thing is getting flatter. Let's toss in another one and see what happens. What are smart values for x that we could plug in here? Specifically, what kind of uneven? They can be positive or negative. There's certain kinds of uneven numbers that will work better here than others. Sorry? No. Look at the denominator. The denominator is 3. Yes, Carson, I saw the gang sign. I appreciate that. So if the denominator is 3, mathematical gang sign. Yeah, that's right. 100% it was. You're part of the 3s. That's good. Just embrace it. Anything divisible by 3 is the number you want to put in here. So, we talked about this before. When you're given something like this, you want to pick smart values. If you have a denominator, pick numbers that are divisible by that denominator. So, 0, 6, well, I don't have 12 in the x's. I do have 9, let's pick 9. Ooh, well, let's try 9. But 9's not going to work for reasons you're going to see here in a second. They give me smaller numbers. Sure, let's pick a 3. I'll squeeze it in there. And let's just do a -1 for fun. -3. So 0 is the easy one. 0 times -5/3 is? Anything times 0 is? Anything times 0 is? 0. Let's plug +3 in there. If I plug +3 in there, I'm going to get y equals -5/3 times 3. Do the division first. 3 divided by 3 is? And then 1 times -5 is? -5. If I plug 6 in here, do the division first. 6 divided by 3 is? 6 divided by 3, or how many times does 3 go into 6? Twice. 6 divided by 3 is 2. 2 times -5 is? So if I plug 6 in there, I'm going to get -10. Do you see why 9 is going to cause me problems now, Scarlett? Because 9 divided by 3 is 3. And 3 times -5 is, as Lucas just said, -15. It's going to be beyond the grid. And then this one, if I plug -3 in here, -3 divided by 3 is -1, and then -1 times -5 is +5. So now let's graph these points. -3, 5 is going to be left, 3 up 5. 0, 0 is going to be right there. 3 and -5 is going to be right there. 6 and -10 is going to be down there. And then 9 and -15 is going to be down here somewhere. Off the grid. And you can see that there's a pattern here. To get from one point to the next, I go down 1, 2, 3, 4, 5, over to the right 1, 2, 3. Down is negative, right is positive. Down 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3. This gives us, then it's negative, so it's going down to the right as we expected it to. And it follows the pattern outlined by the slope. Love it. It's great. Okay, flip the page when you're ready. There's one more, yeah, we've got a lot to do. There's one more thing we can change. And then we're going to put it all together. What happens if we start adding and subtracting things? What does that do? Okay, let's graph the line y equals x plus 0. Josh, keep your hands to yourself. Faison does not want to be stroked gently on his arm. It's weird, don't do it. Yes, it's caressing. But the word caress is like the word moist. It makes people uncomfortable. So I chose not to use it. Okay. I'm going to switch to black because black's easier to see. If I have the equation x plus 0, we're going to pick some values, we're going to shove them in here. I am going to pick the exact same values you guys had before. 1, 2, and -4. The equation has changed ever so slightly. If I plug 1 in here, 1 plus 0 is? 1. 2 plus 0 is? -4 plus 0 is? -4. So nothing's changed here with this first one. It's still going to go through that point, that point. It's just like y equals x. Adding 0 doesn't change anything. The line looks exactly the same. Interesting. Or not. Maybe quite boring. Let's make it more interesting by adding something other than 0. I want to pick we're going to use the exact same points you guys used before. 1, 2, -4. So now the only thing that's changed here is the slope bit has stayed the same. It's still y equals 1 times x, but now instead of adding 0, we're adding 2. What is 1 plus 2? 3. What is 2 plus 3? What is -4 plus 2? Oh, it's not 5, it's 4. 2 plus 2 is 4. What's -4 plus 2? -2. So what has this done? Well, the point 1 and 3 is right here. The point 2 and 4 is right there. And the point -4, -2 is right there. So we can follow the same pattern. To get from this point here, the top point, to the next point down, we go left 1, down 1. So let's go left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1. We can connect those dots. So what has adding 2 done to the line? Yeah, so here when we added 0, when we added nothing, it went through 0, 0. When we added 2, now it's gone through the point 0, 2, or the line moved up too. Fascinating. Sorry? It moved up too. So what happens if we're going to add 4 now? Lucas, do you have a prediction? I only asked you because you had something to say about this one. When your prediction is that it should go up 4. That would make sense based on the pattern that we've seen here. Let's take a look. I'm going to use the same numbers. X, Y, 1, 2, -4. Okay, so if I plug 1 in here, I'm going to get y equals 5. 1 plus 4 is 5. If I plug 2 in here, 2 plus 4 is? And if I plug -4 in here, -4 plus 4 is? 0. Let's graph those points. 1 and 5 is going to be there. 2 and 6 is going to be there. -4 and 0 is that point down there. And we can follow the same pattern. Left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1. We can connect the dots. And as Lucas predicted, adding 4 moved the line up 4. Instead of going through 0, 0, now we're going through the point 0, 4. Where it crosses the y-axis has gone up. Anyone want to take a guess at what they think this one might look like? Hassan Joe? It's all Hassan Joe and Lucas today. You think it should go through this point down here, -4 and 0. Or sorry, 0 and -4. That's your prediction. Another way to read that same prediction is the whole line drops down 4. Okay, let's test it. Let's see if the point that Hassan Joe and Lucas think should be on the graph is. We're going to plug in the same 3 values you guys have used. 1, 2, and -4, and we're going to see what happens. If I plug 1 in here, what is 1 minus 4? -3. If I plug 2 in here, 2 minus 4 is? -2. And if I plug -4 in here, -4 minus 4 is? -8. So let's now graph these points. 1, -3 is going to be right there. 2, -2 is going to be right there. And -4, -8 is going to be left 4, down 8. Oh, look. Hassan and Lucas' prediction follows the pattern. Left 1, down 1, left 1, down 1. There it is. Left 1, down 1. Left 1, down 1, left 1, down 1. We connect the dots. There's the prediction. Love it. We love it when things we predict work out. So what is happening to the line as that number at the back, the thing we're adding and subtracting, changes? There's two ways to interpret it. Either where it hits the y-axis, or to use the descriptions that Lucas was giving the whole time, changing those y values moves the line up and down. We have a name for where a line hits the y-axis. It's related to a sports and military term. The term, let us say Samira is playing basketball later today, and she's playing against some girls from what school? You don't remember what team you're playing this afternoon? Oh, you don't know yet, okay. So let's say you're playing Bateman. One Bateman player has the ball. Bateman passes the ball to another, tries to pass to another Bateman player, and Samira goes in, and she crosses the path of the ball and steals it. That action in sports is called an interception. This value here, where a line crosses the y-axis, we call that point the y-intercept. Or if anyone watched that awesome Cincinnati Bengals Dallas Cowboys game, oh, plenty of those. It was awesome. Dallas Cowboys got crushed. I love it. Only because I have a buddy who's a big Dallas Cowboys fan. I wasn't cheering for Cincinnati, I was just cheering against Dallas. When you're ready, flip the page. Put it all together. This is the y-intercept. Where, because I'm a 49ers fan. Be nice. Where the line hits the y-axis. We give it the letter B. For reasons I have no idea. I don't know why they chose the letter B, but they did. I've never questioned it. I just kind of accepted it. This is given the value of B. And so now we've got the whole equation. The whole equation is y equals mx plus b. The constant number called the y-intercept. We're going to put it there again. We use B to represent it. It's where the line crosses the y-axis. And in real life applications, like if I gave you a word problem with this stuff, it also represents a starting point because at the y-intercept, what's the x value? At the y-intercept, x equals 0. So in all that stuff that we graphed 2 days ago, the plane was descending from 1,800 meters. At time 0, the plane was up at 1,800. That 1,800 represented where it started on the y-axis. I even have that. No, it's on the other booklet. That's okay. So the y-intercept here is, what's the y value where this line crosses that grid right there? -2. What's it here? +2. What's it down here? -5. What's it over here? +2. You betcha, and you betcha. What this lets us do is it now lets us start building the equation. I have one more page for you to flip to. Boom, here it is. Putting it all together. I could have started with this page and just told you this is what it is, but all of what we've done for the last 40 minutes is why this is true. And for a bunch of you, I know the why is important. I hope this is going to be helpful. Here we go. So now we've got an equation. Y equals mx plus b is one of the greatest equations in math. It is simple and it is packed with meaning. This equation has the name. It is called the slope-intercept equation because m is slope and b is the y-intercept. There's your slope. There's your intercept. There's a ton of information packed into this, And so many things in real life can be modeled using this equation. My physics students are doing it all the time. They hate it because I'm making them graph all over the place. So it's very, very easy to draw this line. If you're given the slope, that's the pattern. If you're given the y-intercept, that's the starting point. So, and I'll demonstrate for this. We're going to do a table of values here real quick. I want to pick values of -2, 0, and 2, because that's my denominator here. If I plug these values in, because I know we're running out of time, if I plug these values in, if I plug 0 in here, 0 times a half is 0, and then -3 is going to give us -3. If I plug 2 in here, half of 2 is, -3 is, -2. And if I plug -2 in here, half of -2 is, -1, and then -1 minus 3 is, -4. Let's graph those points, shall we? -2, -4 is right there. 0, -3 is right there. 2, -2 is right there. I can connect those points. I'm going to draw my line. But now that I've been trying to convince you the importance of these two values, we don't need to make a table of values anymore. Rather than doing a table of values, we can do this. Step 1. This guy here is B. This guy here is M. We're going to label M and B. That doesn't say MAND, it says M and B. Step 2. We'll say point 0, comma B on the graph. Label your y-intercept is what we're doing here. Put it on the graph. Step 3, M equals a rise over a run. Like, we're actually going to label that. And then step 4, use M to build a line. It sounds like a lot of steps, but it's really, really quick once you get comfortable with it. So I've already labeled M and B. The equation is y equals mx plus b. M is the number that's in front of the x. The -3, including the sign, is your b value. So that's done. The point 0b is all going to be on the graph. So that point is going to be 0, -3. That's it right there. The slope is 1 over 2. So this is going to be, remember, it's rise over run. So the rise is +1, the run is +2. Or if the fraction's positive, they could both be negative. And now we can just use this pad, use M to build the line. If the rise is 1, we're going to go up 1, and the run is 2, we're going to go over 2. Up 1, over 2, up 1, over 2. Or we could go negative. Negative means we're going down 1 and left 2. Down 1 and left 2. And we can build that line. And we get the exact same line we had from the table of values without having to make a table of values. And I'm done. Thank you. It did kind of feel like today was a magic show. Not a very good one, but a magic show nonetheless. Here you go. I've got your practice. I know, you've got 10 minutes. You may. Both go now. I want you guys to do, let's rock the, hold on. Those are all fractions, those are all whole numbers. You know what? Do them all. There's no part B. Part B is missing. There's 16 questions. Do them all. I assure you, it'll get faster as you go. Use the time that you've got. I know there's only 10 minutes. Use it. Yes, go for it. Boston, Vancouver. You. Don't delete you. The bonus. Nothing to apologize for. Nothing wrong. All the dogs. You betcha.
I just
Wednesday.
might take your class.
Sorry?
I might take your fitness class. Because I like lots of math.
You should. Okay.